This video will go over the Trend Edge Position tool. This is the generic name of the tool in the function list, as you can see here. This tool can be used to measure many edge points along a profile of a target and detect the minimum and maximum position points. It can also be used to calculate a best fit line or best fit circle from the edge profile points that are obtained. This tool is also found in a few other tool categories. In the position angle tool category, it is broken down into specific functions. For line, it will specifically be set for detecting the best fit line from the profile points. In circle, it will be used to detect the best fit circle from the profile points using an arc or ring region. And under tip here, it will simply look for the min and max edge points. So we'll show an example of each one of those. It's also found in the dimensions geometry section. Under detect point, there's tip position, which again is just the min-max position point found of the profile of the surface. Under detect circle, circle along a profile, again we'll detect the profile points around a circle and calculate the best fit circle. And in line angle, it is known as line along a profile. So again, it will profile the edge of the target and calculate the best fit line from the detected points. It's also used within some of the other geometric functions to calculate lines when needed. For our first example using Trend Edge Position tool, we want to find the peak position of a needle, a medical needle. So what we'll do is we'll choose it from the position angle category and we'll choose the tip tool. So what this will do is profile the edges of the target and give us a peak point. So I'll go ahead and add this tool. The very first step in any tool setup will be to register a reference image, which we've done so already, as you can see here. So we'll use this to set up our tool. The next step here is to set up the inspection region. So this is the area of interest on the image where we want to scan and look for the edge points. So in our example here, I'm just going to go ahead and pretty much leave this rectangle most of the screen here, kind of in the center here. So our needle tip is here. This is the peak point we're looking for. And the needle can move around a little bit in this field of view. So we'll set this region up to encompass that area and account for any movement. When you choose the tool from the tip category, as we did, the only choice is rectangle or rotated rectangle because it's going to specifically be looking for a tip or a peak point. Click OK when the region's set. Now we will set up our trend direction. This is the way the direction for which it will slice up the region, if you will, and break it into many small segments. Right now the trend direction is set from top to bottom, so it's breaking the region up into many small pieces starting from the top and going to the bottom, which is detecting this edge, but we want to change that so we can detect this top peak point. So what we'll do is we'll change our trend direction left to right, so it'll break the region from left to right, as you can see here. So once you have set your trend direction, what will happen here is it will detect an edge point, as you can see here by the scan direction from top to bottom, in each one of these segments as it trends across from left to right. So and that's indicated here in the yellow dots here, these yellow points. Each one of these is a detected edge point. So as you can see right here, our judge label is set for max. So right now it's set for the max point. Now in this case, it's the lowest point because in the Y direction, 0, 0 is actually the top left of the screen here. So the max Y point is actually lower on the screen. If we're looking for the peak point towards the top, that would actually be a minimum point. So what I'll go ahead and I'll change that judge label to min, and you can see we are now getting that top peak point. As needed, according to the application, you can also adjust the segment size, the segment shift, and the max number of segments as it breaks up that region. So if you want to get finer details or get more profile points along the edge, you can adjust accordingly. So what I'll do is I'll adjust this to 2, this shift, and the size I'll set for 5, so I'll get a little more detail. Now, since I made the size and shift smaller, I have more segments, so I need to change my max number of segments. So I'll go ahead and set that to 500. So you can see we're getting a little more profile points along the edge. If you click this numeric icon here up top here, you can actually get an indication of how many detected segments they are and how many segments in total. So right now we have 415 total segments, so it broke this up into 415 total pieces across the whole region. And there's 55 of them actually detected at edge points. So you can see we have 55 edge points detected. And again, you can adjust that as needed. As you're setting up this tool, you can also adjust any of the other standard edge detection conditions if need be, according to your target condition. The edge graph will be displayed for the selected segment. In this case, the judge label is set for minimum, so it's actually showing us the edge graph for that segment. If you want to view any of the other segments just for troubleshooting or adjustment purposes, you can actually change it to max, which would be the max point, or you can specify a specific segment. So if you want to scroll around, as you can see here, let me move this up. You can scroll through all the different segments if you need to and view the edge graph for each segment as you go through these. So I'll go ahead and put this back to the minimum point because we want that peak point, and that's it. The last step then will be to set up your judgment conditions of the tool. This is your pass-fail criteria that will make the tool turn no good or okay according to the measured value. The measured value will be displayed here. Right now we're working off the reference image, so it's showing us the value off that. You could also work off the triggered images if you want. So if I fire on some images here, you can see it gives you the current measured value. So we'll go ahead and work off that reference image to set up our tolerance. Now you could set a tolerance on the max point and the min point if you like. And if you click the details here, you could also set a tolerance on the actual detected segments. Again, the number of segments that actually detect an edge point. So if you wanted to fail it if there wasn't enough, you could do that as well. And again, max and min. And then down lower here, you can see position Y. This is the judge label. So if in our example we have set it for min, so it actually matches the min value, but this down here, this is whatever your judge label is set for. So what we'll do is we'll go ahead and set a tolerance on the minimum position. If you recall, that's that peak point here towards the top. And again, this tolerance would just depend on the application. So I'll set, in my example, about 339 pixels in the positive or the upper direction, and maybe 318 in the lower direction. But again, it depends on the application. Once you've had your judgment condition set, you can go ahead and click OK, and the tool is set. You can then test the tool out on different targets and confirm if it passes and fails correctly. So you can see here, here's our good part. The value's in green. It's within our upper and lower limit range. If I trigger on a bad part, you can see the measured position fell above our upper limit, so it turned red and failed. And here's another example of the tip out of position, failing the upper limit. So if it falls outside, any of the measured values fall outside your lower and upper range, the tool will turn red and fail. And if it's within the range, it's green. And at the moment, I only have a tolerance set on the min, but if you had any other tolerances set, if any one of these fail, the tool will fail. For our next example of the trend edge position tool, we'll profile the edge of a target and use those detected edge points to calculate the best fit line from those points, and then pass-fail accordingly if that angle of that line gets out of range. So what we'll do is we'll add this tool from the position angle category and choose line. Again, the first step with any tool setup is to register a reference image if you haven't done so already. So what we'll do is, in this case we haven't, so we'll go ahead and register this current image here. Click register to do that, and that will become our reference image that we can use to set up the tool off of. So click OK. So we can see here is when you choose this tool from the line category, it specifically makes it easy to set this up. All you got to do is click 2 points along the edge point that you want to detect the line. So in our example, we want to detect the edge point of the bottom of this SD card here. So we'll calculate the angle if the card gets too far out of angle. So what we'll do is go ahead and just simply click 2 points along that profile, and it basically creates automatically this rotated rectangle region that will again scan and profile the edges of the surface and get our detected points. So you can adjust the width and height of this rectangle as needed. And again, it's already set up to automatically optimize the conditions. If for some reason the optimized settings are not working correctly for you on your target, you could always uncheck this box and simply set all the edge detection conditions as well as the trend edge segment, shift, offset as needed. We'll go ahead and leave the optimized setting for this example. The last step then is to just simply set your judgment conditions, in other words the pass-fail criteria for the tool. So you can see here we're working off the reference image, but you can also run some parts if you'd like to confirm the angle of other parts. In this example, we want to fail the part if it falls, let's say, plus or minus 5 degrees from the horizon here, so 0 degrees. So what we'll do is we'll put an upper limit of 5 degrees for the upper limit, And for the lower limit, we'll put a -5 degrees. So if the angle of this best fit line, that's indicated here in green, and again, that's the line generated from the best fit line according to these edge points, which are indicated in yellow there. If I zoom in a little bit, you can see those. And it will pass fail accordingly. So again, we can run some parts and confirm. You can see the parts failing there, and it's failing there. So that's it. If you go to the detailed judgment conditions, you could still set a tolerance on the number of detected segments, and that's the number of segments here that actually detect an edge point. So if you want to fail it off that, you can. And you could still fail it off the max and min distance of each point if you want. So just like the example we showed earlier, it still detects a max point and a min point. We can just click OK when the tool is complete, and that completes the setup. And then again, you can run parts to confirm the tool operation. So what you can see here is the angles displayed here, the measured value. It'll be in green if it's within our upper and lower range, and it will turn red and fail the tool if it falls outside our range. And it also gives you the center XY point of that line within your region for reference. For our third example, we'll use the trend edge position tool, but this time we'll profile the edge of a circular target and calculate the best fit circle from the detected point. So we'll go ahead and add the tool from the position angle category and add circle. Again, if you haven't done so already, it will ask you to register the image. We've already done that. We've registered our master golden part. So what we're going to do here is we're going to profile the inner circle here of this washer and measure its best fit circle, the radius and diameter, and make sure it passes and fails within our criteria. So if you choose this tool from the position category and circle, it obviously is optimized for circles. So all you have to do is click 3 points on the circle, as you can see here. So it's automatically going to use a ring, but you can also set it for arc if you want, if you just need to profile just the corner of something. But we'll go ahead and leave it on a ring, and we'll click our 3 points. So what we'll do is click, 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 and you can see it kind of optimizes the ring for us. So what it'll do is it'll scan for edge points within this ring. We can also adjust this ring as needed, the inner and outer diameter, but you can see again the settings are optimized for our condition and we're ready to roll. If the optimum settings are not good enough for your target, or you want to get more detail, as you can see here, you can uncheck the optimize box and still set all the detailed edge detection conditions, again, as well as the segment size, shift, and angle of the trend edge portion of it. So you can always change those as needed. But we'll go ahead and leave the optimum settings. And then the last step simply is to set your judgment conditions on the target. The judgment conditions are the pass-fail criteria for your tool. So you'll set your upper and lower limit on the measured values. So as you can see here with the circle tool we're using, it is giving us the center, the best fit center of that detected circle, as well as the radius and diameter of that best fit circle. So you can set tolerances on the position of it if you like, or the radius and diameter. So in this example, we'll go ahead and just set a tolerance on the radius. So if the radius of the circle gets too far out of range, if the part gets bigger or smaller, we want it to fail. So what we'll do is we'll go ahead and set a tolerance for the upper and a tolerance for the lower. And again, this will depend on the application that you set. So now we're working off the reference image, so we'll set a tolerance accordingly, but you'll set it obviously according to the target. And what you can do also while you're setting the limit is run some other parts through the system if you'd like. So you can see here we have a good part that's passing. If we want to run a part that's slightly smaller, you can see the radius is smaller, the part is failing, and then we can run parts that have a bigger radius and confirm the operation. If you go into the detailed judgment conditions, you can also set a tolerance on the number of detected segments. This is the number of trend edge segments that have an actual edge detection point, so you can pass fail it if it doesn't have enough or if there's some missing. You can also set the tolerances, of course, like we just did on the best fit circle radius, the best fit circle diameter, and circle center. Those are the same ones you just saw on that beginning screen. But there's also a radius max and min and of the tool itself. In other words, what this radius is the radius in reference to the tool's ring itself. So wherever the center of the ring is, it's the radius from that point. And that's the tool. That's the setup. So just click OK when done, and you can confirm the operation. Again, you can see the value will be in green, the measured value, when it's within our upper and lower range, and it will turn red and fail the tool if it falls outside our range. Right now we have a limit just on the radius, but if you had limits on the XY position as well, or the diameter, if any one of these conditions failed, the tool will fail. So just to summarize the trend edge position tool, you saw the three main examples of what the trend edge position tool can do. It can calculate the min-max detected point along a profile. It can detect the best fit line along the profile with target, as well as the best fit circle from the detected target. So when you add it from the position angle category like we did, it's just kind of optimized to those settings. But if you add it from the function list, as you can see here, it's the same exact function. It's just you're free to set the region. So you choose rectangle, rotated rectangle, or ring or arc if you're going to do a best fit circle. So if you're going to do a circle, you would choose ring or arc. And if it's just a simple line, you would choose rectangle or rotated rectangle. So in this case, it's a ring. But like I said, you just set up the same. The tool setup is basically the same. It's just not optimized to the condition. So you have to set up all the settings. So as you can see here, all the edge detection conditions and segment size is not optimized. It starts off with a default setting, but you can adjust those as needed. And best fit circle and line is not on as a default. So basically, as a default, it will just detect the min and max point. But if you want, in this case, the best fit circle, you just simply turn that on. Or if it was a rectangle, you would have a line as an option there to choose. So the tool setup is identical. It's just not optimized for the settings. You just have to set a few more things yourself. But that's it. So that's the trend edge position tool.